we have. Now, 17 doesn't go into 5. Okay, that makes sense. 17 goes into 53. Yes. Okay, 34, add 17 to 34, 51. So 17 goes into 53 3 times. And I'm going to figure out what my remainder is by subtracting 51 from 53. 3 times 17, I end up with 2. Bring down my 2 down here, because that 2 never really left. We were only kind of looking at the first two numbers. 17 goes into 22 once. Multiply that. 1 times 17 subtracted, and we have a grand total of 5. So what this means is 532 is equal to 17 times 31 plus a remainder of 5. So we multiply 17 times 31, we'll get 527. Yep. And then add 5 to get your 532. We could also write this division statement as 532 divided by 17. That is equal to 31 plus a remainder of 5 over 17. So we could turn the 5 over 17 into a decimal if we wanted. Now, about the last time I'm going to do the numbers here, but the process is the same. We're going to have an algorithm like this. We're going to have a divisor. Our divisor is going to be most often just a nice binomial, x plus 2 or 3x plus 4, something like that. Our dividend is going to be some polynomial, either a quadratic, a cubic, a quartic, or a quintic. Don't see too many quintics. We're going to get a quotient out, and we're also going to get a remainder out. The process is still going to be similar. Now, this, I would never ask you to do that. Well, I guess I might ask you to do this one. Here we have the same principle. I'm going to take our divisor is x plus 3. Our dividend is x squared plus 6x plus 5. Now, it's a little bit different because what we're looking at is what goes into, what do I have to multiply x by to get to x squared? We're only really looking here. How many times, or what, if x squared is divided by x, what do I get? Well, I get x out. Okay. So the next line that I'm going to do is going to be x times x minus 3. So that's going to be into this line here. Really is messy. So I found, because if I go x times x squared, or sorry, x times x, I'm going to get rid of, or I'm going to have x squared, which is what I want. I'm then going to, just like I did before, I'm going to subtract this little bit here. I'm going to subtract this guy. Now let's put brackets around it. You know, I've been doing this for 20 some odd years plus some time I was in high school. Now x squared minus x squared is 0. We wanted to get rid of that. 6x minus a negative 3x. So 9x. We often make mistakes here because we deal with we forget we're subtracting a negative, so that's like that. Now I'm going to break down my 5, because I got to deal with him. Now I want to know how many times x minus 3 goes into 9x plus 5. Well, I only really care about how many times does an x go into 9x. Nine times. So this next line is going to be 9 times x minus 3. So when I multiply 9 by x minus 3, I get 9x minus 27. I'm going to subtract that. 9x minus 9x. 5 minus a negative 27. I have 32. Now I'm done because my remainder here is of a lower degree than my polynomial, my divisor up there. Okay. So our division statement, our divisor, x squared plus, or sorry, our dividend, x squared plus 6x plus 5, is equal to our divisor, x minus 3, times x plus 9, plus 32. Now again, if I was to multiply this out, I'm gonna get that end up being back where I the division statement is just another way of writing this. So I multiplied everything out properly, end up with what I need, x squared plus 6x plus 5. Okay, now, I'm going to have to do this a little bit more because we're going to talk about cubics and quartics. But this process is relatively easy if you remember your steps. So we have the next question, x cubed minus x squared minus 4x plus 12. I want to divide that by x minus 2. So I set up the algorithm. Now there are other ways of doing this. I prefer, well, I don't prefer, but I think because we haven't talked about box multiplication for a very long time, it's easier we do something to do with this. So first step, what times x gets you x cubed? Because we're trying to get rid of, we want to do the process to try to get rid of this first term. Well, now notice where I put the x squared. I put it above the x squared term. It's just a tidiness issue that makes life a little easier. So my line that's going to go down here is x squared times x minus 2. So that's what's going here. I'm going to multiply that x squared by both terms. X cubed minus 2x squared. And I'm going to subtract that because I want to get rid of my x cubed terms. 0x cubed did that, right? Negative x squared minus negative 2x. That's a positive, sorry, 2x squared. That's a positive x squared. That's why it's so important to put brackets around that and put the negative sign in front. I guarantee you my math teacher in high school yelled at me, I don't know how many times about that, every day that we did polynomial division. I would never put that down and I'd lose negative signs. All right, so we got this x squared. Let's bring this negative 4x down so we can work with that. So what times x will give you x squared? Well, that's just an x. I'm going to add x to my dividend, or my quotient, I should say. The next line will be x times x minus 2 going into this line. Now I don't write these down, although I think it's a good way to start. you can get into it later and start to skip it. I didn't give you really much room here. So x squared minus x squared, okay, that's good. Negative 4x minus a negative 2x. That's a negative 2x. And bring down my 12. Okay. Okay, so I'm going to write over some stuff here, but now we're at the point, what times x will give you negative 2x? That's negative 2. I have no idea why I was trying to do that. So my next line here will be negative 2 times x minus 2, because I want to multiply that by everything here. So I have negative 2x plus 4. I am sorry I ran out of room. Subtract what's in brackets from above it. Negative 2x minus negative 2x, that's good. Negative 12 minus a positive 4. I end up with 8. Again, I'm sorry I ran out of room. I got 8 right smaller. Questions? So, I'll show you, I'll do one here in a minute the way I do it, because, and again, I've found in the last few years, probably should be doing this for everybody to start with. So my division statement is my dividend over my divisor. In this case, it's equal to x squared plus x minus 2, and then plus 8 over x minus 2. I do have to add that in there. Now, I don't particularly like this statement, but it's one that might show up. I like it in the other form, is the dividend is equal to the quotient times the divisor times the quotient plus the remainder. Because then I can get back to where I started. Is x minus 2 a factor of this one? And why or why not? I ask you if a number is a factor of another number, what do you know about that? If I say 16 is a factor of 64. Well, how do I know it's a factor? A factor is something that divides in evenly to another number. Does this guy divide in evenly? No, because you have a remainder of 8. So x minus 2 is not a factor of our polynomial x cubed minus 2x minus 4x minus x squared minus 4x plus 12, because there's a remainder. If the remainder is 0, then it is a factor. A couple things that you have to remember. Okay. The variables must be written in descending order. So in this case, I gave you a nice easy one. I wrote it as x squared or x cubed, x squared, x, and then constant. But they need to be written in descending order. And they also have to be written, if you have a term missing, you must write that term in. So for this guy here, we're going to take x plus 4, and we're going to, oh crap. x plus 4, and we're going to divide that into, well, my highest power is 3x cubed minus x squared plus 2x plus 4. If you want to do the long division and synthetic division, which we'll get into later today, you have to write it in the order x cubed, x squared, x, and then the constant. So, again, the process. What times x gets you to 3x cubed? Well, that would be 3x squared. So, underneath that, I'm going to multiply 3x squared by x plus 4, and I'm going to subtract what I have in purple or in blue. Negative x squared minus positive 12x squared. Negative 13x squared. That's where we make the most mistakes, is in our integer work. I'm going to bring down the 2x. I could bring down the 4 also, but I don't really worry about it till later. All right, what times x gets me to negative 13x squared? Negative 13x. So I'm going to multiply that negative 13x by x plus 4 to get what gets taken away here. Subtract that, because we want to get what's remaining from when I do this. 13x squared disappears. 2x minus a negative 52x, going to be a positive 54x, and I'll bring down my 4.
Pardon the interruption. Any students who have not had their picture taken yet, please head down to the cafeteria.
And then the final one, what times x gets me to 54x? That's a positive 54. We have our 54x plus 216. Subtract that, 54x's disappear, and I end up with negative 212. I'm just going to write this one as a division statement. And again, this is the division statement I like. She just went that way. I was wondering if she was waiting for you or running away. Now, is x plus 4 a factor of this one? Nope, it has a remainder of 212, so it's not a factor. Now with this one, this next one, it's written in descending order, but it's missing an x squared term. You got y cubed, so my division, I'll start with my y cubed. I have to add 0x squared here. Now, don't write this down. I'm just going to do the first step if you don't write the 0x squared term. Okay, so if I don't write that 0y squared term, I'm going to be trying to take away 6y, or take away negative 3y squared from 6y. They're not like terms, I can't do that. When we do division, long division, we always had a placeholder for, in this case, the hundredths digit. You need to put a placeholder in here to have the y squared term. So we'll put in a placeholder 0y squared minus 6y plus 20. Now we can go ahead. Y squared times y minus 3. We have y cubed minus 3y squared. Now again, this is how I would do it. I don't normally put the stuff on the side, but please feel comfortable doing that. I'm going to subtract that to see what I have remaining. You make a mistake here and usually put negative 3y squared down. 0 somethings minus negative 3 somethings. That's positive 3 somethings. And again, I'll bring my negative 6y down because I know where I need that. So what times y gets me to positive 3y squared? It's positive 3y. 3y times y, 3y squared. 3y times negative 3 is negative 9y. Subtract. The 3y squareds disappear. Negative 6 minus negative 9, again, is a positive 3. Bring down my 20 because I know I'm going to need it. And then we have plus 3. We would have 3y minus 9. Now, if you're not comfortable doing this way, I'm perfectly valid. It's a perfectly valid way of doing it, just keeping track of everything. So again, this is not a factor because it has a remainder of 29. And my division statement for this and I kind of ran out of room. But this is an algorithm. This is not the only way that you can do division. I can think of 2 other ones that I'm very comfortable with, and I'm sure there are many more out there. And if I had an extra week, I would teach you the one that I think is actually easier, box division. But you need an understanding of how to do box multiplication. What I would like you to do for the next, and I guess we have 3 questions. So I would like you, while I walk around, I would like you to do the division of these 3. This is the whiteboard work that I want you to practice while I take a look at it. I will grab my water.
So what we have to multiply that by is 4x. So you want to fill this guy to higher degree than what you left. So that was the one that interact on the exponent function. Should be underneath. Across the exponent. -2 minus a negative. I have a 3 minus a negative. Yeah. So here you have 0, minus, you should have a negative. 0, equals hold on, let's do this. No, I don't think it is because negative 3 x, negative 3x, negative. And that's where we put everything you're finding, you do those. So you were fine because he did a negative. She had a positive. Because here, you have positive 12, which is the positive. So here, can you give me a division? You don't know the column. You put either. We're just going to write a division statement like we work. Polynomial, this polynomial, this that, times that. So our divisor is x. I'm going to be, you're going to be. Basically, what it is, this is this. And then you multiply this together to get 12. I didn't give you 12. What is the division statement of this? Yeah, actually, what I want to do is not that. So my division is oh, you did it backwards, and that's too much labor. I don't do that.
Okay, so a couple questions with the polynomial here. What is the polynomial? Well, I don't know what the polynomial is, but I divided the polynomial by x minus 3, so my divisor. When I divided that by x minus 3, I got a quotient of x squared plus 3x minus 6, plus I have 5 left over. So now all I need you to do is expand, do your distributive property on this to get the actual polynomial. And yes, this is 8x. I don't know why, probably I didn't erase something properly. I'll give you about another 3 minutes and then I want to go into the easier form. Although it only worked for certain groups. There you go. First step.
put it up here. So you know, have to divide or start. Minus my answer. One thing, you're very much like me. So it doesn't hurt to take as much sleep. And that's not it. Like, so what number multiplied by 2x? Gosh, bro. But the only thing that I would try to do it, if you look when I do it, or even when John does it, he's working all. So if you have to change this,
Okay, so looking around, we have an understanding a little bit of long division. Okay, so what do we know about 2x plus 1 and this polynomial? Because we've got a remainder of 0. What do we know about that divisor 2x plus 1? Sorry? It's a factor. Now I could continue on. I won't, but I could make you continue on this. Now, long division takes it's a lot of space. And it takes a fairly long time. So there's another algorithm that we can do that works if we are dividing by 1x and something. Over here, 1x plus 4. We are not able to do synthetic division for this equation, or this division here. Wow, sorry. Because we have a 2. We're not able to do it without a little bit of extra work. Now, the first time I actually ever saw synthetic division done correctly with that 2 was a student about 4 years ago. Even I did, like, I'd never done it before. I looked at it and went, he's right. I didn't like it, but he was right. So it is possible to do synthetic division when you have a number in front, but I'm not going to teach it to you. If you want extra work, we can go over it, but I prefer to do long division when I'm forced to. Basically, it's another algorithm, and we're going to do this. We're dividing x squared plus 6x plus 5 by x minus 3. We already know the answer to this. But synthetic division takes only the coefficients in front of the dividend, and we put it inside this little box. We take the 0 of x minus 3. We put a 3 here. Now, the reason we take the 0 is now allows me to add. I think, I don't know, I made a mistake, or when I was taught this, I always did subtraction, but adding is easier because we don't mess up as often on our integer work. So we take the 0 of our divisor, and we put it here. Now, since we're dividing by 1, 1x into x squared, this 1 will always be the same. So I'm just going to break down that 1. That 1's just going to come down. Because we're dividing by 1, that number, this number here will always be the same as that number. Now I'm going to multiply 3 by 1. So I'm going to take what's outside the box and multiply by what's down here. And then I'm going to add these two numbers together. Life becomes easier when you add. And now I'm going to multiply 3 by 9. And I'm going to add these guys. Now, what we have here is these two guys are the quotient. And what's left in this box here is the remainder. So the last box is always the remainder. This box is, these two boxes, or if there's 3 boxes left over, there's going to be the quotient. Now, what happens when you divide x squared by x? What do you get? You get an x. So this is actually 1x. And then we're going to drop, or we're going to lose a term because we have x plus 9. We just keep decreasing the power of our variable here. So we did this earlier. We got the exact same thing. A lot quicker, a little more compact, etc. But we have to make the same rules. We have to have the powers of x, or whatever variable, in decreasing order. And we have to put placeholders if we have a power of x missing, like 0x squared. So let's just quickly do this one. We are dividing by x minus 1, and we have this as our dividend. It's in decreasing order. It goes x cubed, x squared, x, and then constant. So writing only the coefficients in my box. The 0 of x minus 1 is 1. And I said, because I'm going to divide x into 2x cubed, I'm going to get 2 down here. So I'm just going to drop that 2 because it's going to have the same, it's always going to be the same when you do synthetic division. 1 times 2 is 2. Add them together, -1. -1 times -1, or 1 times -1, add them together, -9. Negative 9 times 1, bring that guy here, add them together, 6. So there's your algorithm. Now we have to make sure that we get the proper polynomial out of this. So our polynomial, well, they're divided by x minus 1, so we'll put him there. The polynomial that comes out of here, this is my remainder. I have 6 as a remainder in there. The coefficients of our quotient are 2, negative 1, and negative 9. So I'm going to go 2x squared. This term is always 1 less than what we started with, 1 less than the dividend. And then I'm just going to keep losing powers. 2x squared minus x minus 9. Plus 6 being our remainder. Okay, so does everybody understand why I just dropped this number here? Because we're dividing by x, 1x into 2x cubed, I'm going to get 2x squared out. Now, be careful in this one here. You have missing terms. You actually have 2 missing terms, and it's not in order by any stretch of the imagination. So please do the synthetic division on these two, and then you can figure out what R and you can figure out what P, Q, and R are by completing the algorithm there. So that's your whiteboard work. Once you're done that, you can do the homework or start on the homework. I want these 2 to be done by long division, these 3 by synthetic division. Nope.